we're going to try some nested structures now. So I'm going to actually create a new project. I'll make it a console app. I am going to call this one section 4.3 nesting. Make sure that it's on my desktop or wherever I want to create it. Yep, we will save those. And then I'm going to clean this one up a little bit. All right, we're going to be nesting an if statement inside of a for loop. So we're going to determine if a number is prime or non-prime. So we're going to prompt the user for a number, like the number 7. Excuse me, but my dog is coughing over here. So we're going to prompt the user for a number like 7, and then we're going to start dividing their input number, not with 0 or not with 1. We're actually going to start at 2, and then we'll divide it by 3, and then 4, then 5, then 6, all the way up to 7. And if we can get up all the way up to 7, for each one of those iterations through that loop, we'll loop through that. And the if structure says that if their number divided by that 2, 3, 4, 5, 6 is, if the mod of that is 0, that means that the number is not prime. If that modulus is equal to 0, then the number is not prime, and we're going to say, I'm sorry, the number is not prime, and we're going to drop out as soon as we find an evenly divisible number. But if we get all the way up to dividing it by 7, and we haven't found an evenly divisible number, then the number is prime. So that will be the if statement inside of the for loop. So I have a little bit of pseudocode started here. So we're going to declare a couple of variables, numerator and denominator. We're going to prompt them for the number. We're going to read it in as a numerator, and then we're going to start the looping structure. And so inside the looping structure, we're going to use a for loop for this, because we're just going to be counting up, and for loops are really good at counting up or counting down. And inside of here, we're going to say something like, if the numerator divided by the denominator is equal to 0, then the number is not prime. And if that's 2, we're going to tell them it's not prime and exit the program. And that was my if statement. I should tab in. If it is not prime, we're going to tell them it's not prime, and we're going to exit the program. Otherwise, we're going to loop again. So for each iteration through the loop, we're going to see if the numerator, if their number is divisible by the denominator. We'll increment the denominator. We'll see if the numerator is divisible, evenly divisible by the next one. And we're going to continue all the way up. And then ultimately, if we have not exited the program, we're going to tell them that their number is prime. All right, so let's circle back around and add a little bit of details. We know that the variables that we're going to need are the numerator and the denominator. We're going to capture their value as the numerator. We're definitely going to use a for loop here, because for loops are really good at counting. And then what I want to say as the number is prime, I want to say something like 7 is a prime number. So I'm going to try to build a cout or a print statement that says that. So let's come out and we'll say we're calling the numerator, or the number that I read in as numerator, and then we'll say is a prime number. And I'll even force a new line inside of here, or maybe we'll force a couple of new lines inside of there, mainly because I know that we have a lot of things that are printing after that. I'm going to put a space before the word is, just to make it a little bit more readable. We'll come up here right now. It doesn't know what num is, so I'm going to create int. We're actually going to make this, instead of an int num, we're going to make this an unsigned long, and we'll call it numerator. And then for our denominator, we'll also make that one unsigned long. So we'll say denom, so that they can key in large numbers if they want. All right, so we're going to prompt for the number, and we're going to capture it as the numerator. So we'll ask them for enter a number. And then we're going to read it in as numerator. We'll just call it num, since obviously I have a hard time spelling things. And I can't even spell num correctly over and over again. And then we're going to start our for loop. So here is our for loop. So we need our start position. So we're going to take the numerator and we're going to start dividing it by the denominator. Now I don't want to divide it by 0, and there's no point in dividing it by 1. So we're actually going to start our variable called denominator, D-E-N-O-M. We're going to actually set that at 2. That's where we're going to begin our division of their input number is 2. So I'll put my semicolon, and we're going to say as long as that denominator is less than or equal to the number that they keyed in, or the numerator, then we're going to increment our denominator. So we're going to divide it by 2, then by 3, then by 4, then by 5, up to whatever number that they keyed in. So I'll put my opening curly brace here. I'm going to have to come down here, and we'll put my closing curly brace here. That would be end. This is the end of my for, and I'll drop it down just a little bit. All right, so inside of the for loop, as we're looping through the denominator, incrementing up through the denominator, we said if the numerator divided by or mod the denominator is equal to 0, that means that it's evenly divisible, which means that it is not a prime number. So my if statement here is going to be if the numerator mod, we will say mod denominator is equal to 0, that means that it's evenly divisible. There's no remainder, which means that it is not a prime number. So I have my opening curly brace. I'm going to come down in here and put my closing curly brace. I'll say that this is my end if. There is my end for. And inside of my end if, we're going to tell them it's not prime, and then we're going to exit the program. So I probably want to tell them that something like, I'm going to say something like 16 is not prime. So, well, 15 is not prime. So this is how I'm going to tell them that their number is not prime. So whatever that number is, and then I'll say is not prime. I'll force a new line after that. And then I'll even say it is divisible by is not prime. So inside of here, I will say it is divisible by, and then, let's close that. And then it's divisible by the denominator. So if I divide it by 2 and it was evenly divisible, then it's divisible by 2. If I divide it by 3 or 4 or 5 and it's evenly divisible, that denominator is the evenly divisible number. All right, here we go. So it's Visual Studio helps me by putting extra double quotes in there. All right, there we go. So we told them that it's not prime. Now I need to exit the program. So I'm going to say something like press any key to continue. Or excuse me, not continue, to end. We're going to tell him that it was not a prime number, evenly divisible by the first one that we came to. So I'm going to tell him to press any key to continue. And then I'm going to use underscore. That's going to be an underscore get character or get ch. So this is going to hold the prompt blinking, where I'm waiting for some kind of an input. So I'm looking for any key, press any key, and then we are going to exit the program. Now, this get ch right here, we're going to have to include conio.h. So we're going to go back up to the top, and we're going to, in order to use get underscore get ch or get character, we're going to come back up here and we are going to pound include conio.h. so that we can use that get ch, which means that if it's not divisible, I just want to exit the program, and we're going to do that using get ch. But if we don't exit the program, we're going to continue our for loop for each incremental value of the denominator, and finally, if we drop out of the for loop, then we're going to tell them that the number is prime. So we're going to say the number 17 is a prime number. All right, so let's run our program and let's see what we get. So I'm going to put in something that I know is not prime, something like 15. Well, 15 is not a prime number. So it's going to tell me 15 is not prime, it's divisible by 3. Press any key to continue. That underscore get ch is what is holding the blinking cursor there. As soon as I key in something, it will then exit the program. If we run it again, and I'm going to put in something that I do know is prime, like the number 17, I know the number 17 is prime. We're going to say that 17 is prime, which means that we're going to add one more thing to our program. Inside of our for loop here, where my condition says denominator is less than or equal to number, we're going to actually divide the whole thing by 2. So I don't have to go all the way up to 7. All I have to do is go up to half of that. So let me run it one more time and see if that division by 2 as under my condition will change the fact that 17 is a prime number. So we'll run it, and I happen to know that 17 is a prime number, divisible only by 1 and itself, and now it tells me that 17 is a prime number. I'm pretty sure 13 is also a prime number, so we'll come back in here and we'll try 13, which is a prime number. And if I run it one more time with a 12, I know 12 is not a prime number. So it's going to tell me it's not a prime number, it's divisible by 2. Press any key to continue, so now it's holding my window open, and I press enter, and the program will close.